Hello guys, can you hear me? Perfect. Okay. All right, I think there's like around a 5-second delay, but I don't think there's too much we can do about that. It's pretty low. Let's get the actual stream started. All right. So actually here, let me open up chat on my phone just so I can check it out. All right, so this tutorial, we're gonna go over a few things. We're gonna go over flowcharts. Flowcharts, and we're gonna go over the number game and how to implement it. And we're gonna build the flowchart for the number game. And then we're gonna go over anything you guys want. So we can help you out with assignment 2 if you need some help, or answer other general questions about either the assignment, Python, or the course in general. So shouldn't be too bad. All right, okay, let's get started. So, have you guys heard of the number game? Has Dr. Moore mentioned that at all? I think Dr. Moore should have mentioned the number game. And it's basically this game where the computer guesses a the computer guesses a number, and you keep guessing what that number is. And if you're too high, like if you're higher than the actual number the computer guessed, it tells you too high, guess again. If you're too low, it says too low, guess again, and you keep guessing until you've got the number on the dot. So the way I'm gonna set this up is I'm gonna show you kind of in words how the number game works. Then I'm gonna follow it up by showing you how the flowchart would look like, which is part of the lecture material. And then we can code it in Python, and you guys can see that too. So, hey Fatu, yeah, I don't think this is the same content as what Swale covered in his tutorial. I think his tutorial went over more of like installation of Python and then some example problems, like some basic Python problems. This is going to be a bit different. You can stick around and see whether you want to stay or not, but obviously nothing is for grades. So I'm basically just gonna write in text what happens in the number game. So basically, here's what happens: the computer chooses a number, and then you guess a number. And if your number is greater, let me change this. If your guess is greater than the number, then we're going to say too high. And if your guess is lower, too low. Cool. And this is assuming that that your guess isn't the number. Because first we're going to check if you actually guessed the number right. And if you guessed the number correctly, then you've won the game. But it's only if you haven't guessed the number correctly that these questions get asked, whether or not your guess was higher or lower than the number. Right? So we say, basically, and we keep asking this every single time they guess. So we're going to put this in a while loop. We're basically going to say while the guess isn't equal to the number. We're going to do all this stuff. And then we're going to you guess a number again. Cool. And then once you've actually guessed the number correctly, you've won. That's kind of the whole the outline of how our program is going to look. And so, do you guys know what flowcharts look like? Do you guys remember annotated flowcharts? I think he should have gone over those in lecture. Just let me know if you guys know what annotated flowcharts are or what they're like. Okay, we can build one. Here, actually, you guys let me know. I've built one earlier for the number game. Do you guys want me to go over and basically reconstruct one for you from scratch, or do you guys want me to show you the one that I've already built? I can do either. Okay, reconstruct. Yeah, I think reconstruct is better too, because it gives you kind of a cool. Okay, yeah, we're going to reconstruct it. Let me set up paint. All right. Here we go. Can you guys see this? We're trying something out. All right. So we can go back and we can reference our outline for the program. So basically, we're going to try and convert what we've written here in plain English to flowchart. And basically, the way the flowcharts are constructed, or at least the way Dr. Moore constructs them, is you have all these arrows connecting either statements or conditionals. And so let's get started. So hopefully this looks okay. I'll try and make this a bit bigger. And this is where we're going to start. We're going to start here. And basically, we're going to have a statement here. Because the first thing that we do is we do a few things that are statements in Python. And the things that we do are, there's actually like a message that we print or something like that. So it kind of goes, hi, welcome to the game. And you can, and it prompts you to enter a number. So we can basically say, what are we going to do in this first statement? We can decide. So we can print the intro message because there's going to be an intro message. We can assign stuff. That's an important thing in statement blocks is assigning. So you can assign variables. And here we're going to say number becomes a random integer from 1 to 100. Right. Keep in mind, this isn't actually pure Python. This isn't like you don't have to be perfect syntactically, right? You can make generalizations and kind of say what you mean in kind of like a pseudocode, if you guys know what that means. All right. And what else do we need? We also need to actually take in the first guess because the player is supposed to make a guess. So we're going to say guess becomes input. So these are both these are all like pseudocode explanations. All right, and then from here we go on to a conditional. In the flowcharts, conditionals are kind of represented as diamonds, and statements are represented as kind of these rectangular blocks. So we can use that. So you can say, while guess is not equal to number. This is how you say not equal to, by the way, in Python, if you guys don't know. There's a couple ways to do it, but this is the one that you'll see in most programming languages, and you can also do it in Python. So if the guess is not equal to the number, right? First, let's actually consider the case where the guess is equal to the number. So this says guess not equal to number. So if this is false, that means that the guess is equal to the number, right? It's kind of like a double negative. So we can draw a line here that is this is our no. So if this is false, then we can basically say that the game's going to be over, right? We can say right away, print game over message. And that takes care of that. And now we can work on the rest, which is this big, makes this even bigger, this big yes branch. All right. So if the guess is not equal to the number, which means this is yes, right? Then we're going to do some stuff again. We're basically going to tell the user that they've made a mistake, right? They're obviously not guessing the right number. So we're going to say print, let's just call it incorrect guess message. And then we're going to ask some questions. Now we're going to make a conditional. We're going to see whether or not their guess was greater than or less than the number so that we can help them on their next guess. If their guess was greater than the number, then we're going to tell them too high. Otherwise, we're going to tell them too low. So this can go to a conditional branch. All right, sorry. This can go to a conditional branch right here. And what we're going to ask here is, was the guess greater than the number? Also, guys, if you could just say anything in the chat. I'm not sure if my chat's freezing up or if it's just silent. Just trying to check. Keep going though. So if the guess is greater than the number, we have once again our yes and no branches for the conditionals. So we can draw those. I'm gonna have this. All right, cool. You guys are still there. Great. We'll have our no branch, right? We can say if also. So here's the thing. If guess is greater than number. If this is true, then we know that guess is greater than number. But if guess is greater than number is false, then we actually know that guess is less than number. Guess can't be equal to the number because we determined that guess was not equal to the number up here. So if you follow this path, we've already kind of determined here that guess is not equal to the number. So once we go here and we ask, is guess greater than the number? If that's false, then we know kind of by exclusion that guess has to be less than the number. So we can have this message here that says, well, we know guess is less than the number, so we can say print too low message, right? And we can have something here. I'm kind of running out of space. Oops. Print too high message. And so now that we've printed these messages, what's next? Well, we're going to ask the user for their new input, right? We're going to ask them for to guess again. And the way we can do that is first we have to realize that regardless of whether their guess was higher or lower than the number, we're still going to ask them for a new guess. So both of these branches are going to come back and meet up because we need to do the same thing after both of them. I'm running out of space, so let me do this. Right? We need to do the same thing again. And we're basically going to say, this is going to be a statement block again, because we're just doing another statement. And we're going to take their guess again. How are we going to take their guess again? We're going to reassign the guess variable to input. Cool. And this is the important part, is that once we've done this, right? Once we've taken their guess again, we're going to go all the way. It's going to be messy. It's going to be really messy. Oh boy. We're going to go all the way back to our question: is their guess equal to or not equal to the number? And that's basically it. That's the game. If you think about it, all the cases are covered here. And this arrow that branches back towards a conditional, this really represents at its core what a while loop is actually doing. A while loop is checking a conditional, and as long as that conditional is true, it runs something. And then once it's done running, it checks again. Then it runs again if it's true. It checks again, and it keeps checking, and it will keep running whatever's inside the while loop as long as it's true. So so you see that the yes branch is the branch that leads it back to the beginning. If you take the no branch, it ends right here. Your game over. There's no branches that come out of here, so you'd be done. So this is it. Does anyone have any questions about this annotated flowchart? Anything about like the symbols we use or the way things are formatted? If anyone has any questions about this, just let me know. Or if someone doesn't understand some of the logic of the game. Here, I'll check chat. How to visualize while in chart. Okay, yeah, I can go over that again. So where is that? So the way a while loop works is, so you know how an if statement works, right? An if statement works so that if you basically check a condition, and if the condition is true, then you execute whatever's inside the if statement, right? That's how an if statement works. A while statement or a while loop is basically doing the same thing, but on repeat, right? It kind of repeats that process as long as, you can think of it as long as this condition is true, do this. That's what a while loop is. So if you think about what that means logically, it really means something very similar to what we've done, if not identical to what we've done. It basically means checking a condition, and if that condition is true, right? This is saying that yes, the guess is not equal to the number. If it's true, then we execute some code that's all of this stuff, like all of this stuff. It's this code. And then we go back and ask the same question. That's what a while loop is. So that's how we visualize a while loop in the chart. We basically use an arrow to branch back to right before a conditional. Because once we branch back here, we're going to ask this question again. This is what's going to be next. Is that clear? I can explain further if you want. Perfect. Okay. So let's see. Right. The next thing we're going to do is we are going to visualize it. Let me try this again. So here's Chrome, and here is our tutorial. Oh, wait, we have another question. Okay. With a loop statement, how do you define what the condition is using this flowchart? Well, I'm confused on what you mean by that. Do you mean right? Because okay, I think I might understand what you mean. You're talking about like how a for loop has a looping condition. You're saying how do you define what the looping condition is in the flowchart? Okay, cool. So with a for loop, what it's basically doing in a standard for loop is you're basically checking to see if some looping variable, usually we call it I in programming, it's a convention. You check if I is within some bounds, and that's your looping condition. And you keep looping as long as I is within the bounds, right? So the condition is usually something like, for example, let's say you wanted to run for I in range 5, right? This is a standard for loop, and we're going to run it 5 times. That's a set amount. There's a looping variable here. It's called I. So your looping condition in the chart would be keeping track of I. So we would basically have a diamond like this. It's really thin. That inside of it, we say, as long, oh, that's really weird. As long as I is less than 5. Right? That's how we do it. And we basically do the same thing. And you have to remember to increment I at the end of every iteration. So pretend we're back here, right? This is our while loop. If we wanted to make this a for loop, we could say our looping condition right here at the top, which is our looping condition. We could say I is less than 5. In our yes branch, we do all of our statements that we need to do. We do whatever we need to do. And at the end, we have another statement that increments I by 1. So you could have a statement here that says I plus I equals I plus 1. Oh boy, this is weird. That'll work. Cool. That's that would basically simulate a for loop because we would increment I, go back to the top. And so when I finally is equal to 5, this is going to fail. I is less than 5 is going to fail. And we'll take the no branch and we won't loop anymore. Is that clear? All right, perfect. Let's get to the coding. Is the fun part. So, let's see. You want to code something. Oh no! Oh shoot! This whole time I wasn't streaming. Oh geez. I don't think you guys could see. Sorry, Albert. I was on. Oops, this is a mess. I was drawing in Paint, but I had the stream set to Chrome, and you guys couldn't see it. I was basically saying if you had a for loop, which was for I in range 5, then your looping condition would be 5. That's what I was drawing. And your looping condition, if you wanted to replace this while loop with the for loop, you would have your looping condition in this diamond in the same place as usual, right? Oh, you could see the Paint drawing. Okay, I don't know what's going on then. Okay, some people weren't. Sorry. Okay, I'll just finish it up quickly again. But basically, your looping condition would be here, and it would be I is less than 5. And you would keep looping, but you would remember to increment I at the end. So you do whatever code you need to do, increment I, then come back to the top. And once you've looped through all the loops up till 5, and now I is equal to 5, then this condition is going to be false. I is less than 5 is going to be false. So you're going to take the no branch, and you will not loop anymore. So that's how you would represent a for loop in a flowchart. So what I can do too, guys, is I can basically throw in. I can upload this picture to like either Piazza or Avenue or something, and you guys can take a look at it afterwards. But there's also a full explanation and examples on his lecture slides for how to build a flowchart. All right, another question: how can we limit on the number of guesses? Well, it's simple. If kind of the same thing we were doing, right? Instead of a while loop, which keeps going on forever as long as the guess is equal to the number, you could make it a for loop, which is exactly what we discussed. So let's say if you wanted to make the number of guesses 10 instead of an infinite number of guesses, you could literally put in here I is less than 10, right? And since I is less than 10, if we do all of this stuff and then we increment I, don't forget, we'd actually also, at the beginning here, we'd have to add something in. We'd have to make, we'd have to assign I. So imagine this box was a bit bigger and we could fit that in. That would basically make it work. Because then we'd say, is I less than 10? Yeah, it's 0. We do all this stuff. We basically make them guess, right? And we give them their message. And then we increment I. So now I is 1. Make them guess again. Blah, 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 blah. It'll go from 0 through 9, which is 10 guesses. When I is now equal to 10, it'll ask this question. The answer is going to be no, because I is no longer less than 10. I is equal to 10. So it'll take the no branch, and it'll be game over. Cool? Cool. So that's it. I'm going to try and show you guys the code now. So hopefully that's working on the stream. And we can start coding up the examples. So, one thing is that the way we're going to determine what the computer guesses as its guess, right? Because the computer has to pick a number first, which is what we're trying to guess. We want to make that computer's number random. Every single time we run this program, we want it to be a different random number. So we can use the math library. So we can say, oh, this brings me to a great point too. Some people were having trouble understanding the difference between things like this. Right? The difference between import math and from math import something. And I can show you guys what that basically, how that works. Give me one sec. Cool. Yeah. But first, let's just go with something like, we actually don't need math for this one. We need random. So we can say random. So first we can say print, and we can have our intro message, right? Let's look back at our flowchart to show a screen instead. If we go back to our flowchart, the things we need to do are print an intro message, assign the number to a random integer, take input from the user, which is the guess, and in this version we had a fixed number of guesses, but first we can implement it as an infinite number of guesses using a while loop instead of a for loop. Cool. So yep. Let's do the intro message. We'll say, hi, welcome to the number game. Right? What else we got to do? We got to obviously take in the number. So we'll say number equals random.randint. We'll say 1 to 100. And let me explain this line. So random is a module which has a bunch of different Python commands or Python functions that you can use. So when you import random, you can access those functions from random using random.randint. The difference between import random and from random import a function that we want, for example, randint, is that if we do this, we're basically importing this exact function into our program. And then we don't need to have this prefix here. I have a Piazza post on this, on Piazza, but that's basically the difference. You can have just randint without the prefix and the dot. But it's good practice to actually just import random. The reason being, the reason why it's good practice to have it in this form is because you can do that in my, what's going on? Then now I have two duplicate functions, and that's confusing, and Python's not going to know which one to use. It's going to use the most recent one. So in order to avoid that, if we use import random instead of from random import randint, then you have this prefix, and now they're different. Now this randint that I defined myself is different from this random.randint, right? They're distinct. So let's keep going. We're going to assign a number, and now we need to take in our user's input. So we can say guess equals input. Let me check chat, make sure nothing's wrong. Cool. Right? And here's the thing. Actually, I'll leave this. Does anybody see what's wrong so far? You might actually not see what's wrong so far, but there already is a mistake if I just keep going. But I'll keep going and I'll check with you guys to see if you've spotted the mistake. We're going to check, just like in our flowchart. We're going to check if guess is not equal to number. And we're going to say if guess is greater than number, we're going to print too high. Say incorrect guess. Too high. And else, print, we can copy this. It's the same thing. And we'll say, oops. And we'll say too low. Because if guess is not equal to the number, like we said earlier, and guess isn't greater than the number, then it has to be less than the number. Cool? There's a double quote here. All right. Then Python, when the user types in their input, it's treated as a string, regardless of what you're actually typing. Even if you type the number 43, Python's going to treat it as the string 43, not as the number. So you need to convert any inputs you take in from the string format, which by default it's going to be in, to whatever format you need it to be in. So that's going to be in int, which is what we want. So we can basically wrap this input in an int function. We're basically saying, here's our input. We're going to take the integer of that, right? We're converting it to an integer, from a string to an integer. And we're going to do the same thing down here. Cool. And what else do we got to do? Oh, true. Well, first, this shouldn't be an if. This should be a while, because we're going to be looping. It's looking pretty clean. Once we're done, the while loop, right? When this is finally false, which means guess is equal to the number, which means we actually guessed it right, then it's going to jump down here. It's not going to run this code inside the while loop. It's going to jump outside of the while loop down here. So we can say here, we can print, you guessed the number. Okay. Cool. That's in a string. And to make this a bit cooler, you can actually put messages inside your input calls. You can say, you can put a string here, and when Python tries to grab input, it'll print the string at the same time. So we can say, please enter your guess. We can say, oops, quotes, guess again. Cool. So, do you guys see any mistakes? Waiting for you guys to answer. Let me know. I should probably go back here. There shouldn't be any mistakes. I'm not sure if there are mistakes, but we'll see. We'll run it and we'll find out. Okay. This happened. We can say 30. It says too high. So let's try 20. We're still too high. Let's try 10. All right, now we're too low. Let's try 15. We're too high again, so we know we're somewhere in between 10 and 15, exclusive. Let's try 13. Too low. So you guys know which number it's going to be. It's obviously going to be 14. And there we go. We finally get our game over message, which means on this guess, like our program was right here. It said guess again. We said 14. It went back up here, and it said, is the guess not equal to the number? And we had actually guessed the number, because number was 14 all along, and we guessed 14. So now, this was actually false, because we're asking, is guess not equal to the number? Well, it is equal to the number, so this is false. So instead of running this again, we jumped all the way down outside of the while loop, right? Down here to this tab, and we ended the game. Is it clear to everyone how that program kind of worked? Let me know. If anyone has any questions, feel free to shoot, and I can try and answer them. All right, cool. It's good. Any questions at all, guys? Feel free to ask, because this is really your best time to have like a one-on-one chat. It's a lot easier than, like asking a million Piazza questions and then having to wait for a response. Even though I think the Piazza responses are pretty quick, but yeah, this is a pretty good opportunity to ask any questions. Can we do an example where we limit the number of guesses? Yes. I was actually just going to do that after this if no one had questions, but we can definitely do that. Can you guess the number correct under while loop? Yeah. Let's do a for loop. So remember what I said, right? If we're gonna use a for loop, we need to have some kind of looping variable. We're gonna call it I. So this looping variable, we're gonna have to initialize it at some point. We're gonna have to initially give it a value. And the way we can do that is by saying I equals 0 at the top before we start our while loop. Or I guess now this is going to be a for loop. So we're going to say, oops, I started it. How do I terminate? Kernel, cell. There's a way to interrupt it. I know there is. Shoot. Oh, interrupt. Okay. So it didn't work. Oh boy. All right, I'm going to refresh. So let's initialize our looping variable. We're going to put it right here. And we're going to say I equals 0. So now we're going to have a for loop instead of a while loop. And we're going to say well, actually, we don't need to initialize this at all up here. In our flowchart, we did because it's kind of the layout. But in for loops in Python, when you say for I in range of a certain number, let's say you get 10 guesses. Thanks, Albert, by the way. Yeah, I'll do that next time if it doesn't work or if it freezes up. For I in range 10, I is kind of generated as a variable here. So this variable is going to be local to whatever's inside your for loop. So I is going to exist here, and it's going to increment on its own every single time the loop goes. If you had a while loop, you would actually need to increment it manually, because in while loops, there's no looping variable by default. If you want one, you have to make one. But here, we get I. So we're going to ask if guess is not equal to number, right? If guess is not equal to number, then we're going to do all of this stuff, right? So we tab that in. By the way, guys, very important. I'm sure most of you know this by now, but tabbing is the way that Python knows what's inside a certain block. So you have different blocks like if statement blocks and for loop blocks and while loop blocks, right? And the only way Python knows where those blocks start and where they end is via tabbing. So tabbing is very important. So keep in mind that I'm tabbing all this stuff inside this if statement. So all this happens only if this is true, right? If guess is not equal to the number, then we print these incorrect messages, and we say, we take the new input. Cool. So here's what we're going to do. We're going to tab back out here, right? So now we're in line with this initial if, and we're going to say else, which basically means, right? This else is referring to this if statement. So if guess is not equal to number, if that's true, then guess is not equal to number. Else, well, the only time it's not equal to the number is if the guess is equal to the number. So basically, if the guess is equal to the number, we're going to say oops. Okay. All right. I don't know if I went offline, but I think I'm back. Do you guys let me know if you can hear me right now? Here? Okay. All right. Sorry, I think that was internet interruption, but we're back. So, and someone asked, could we print the number of guesses we have left after each guess? Yeah, we absolutely can. That's a great thing to do. Let's do that actually. So we can say here, right? Because we're saying if the guess is not equal to the number, we can print and we're going to use our looping variable I, because since I increments every time, I is going to be a great way to determine how many guesses we have left. Because when I is 0, we still have 10 guesses left. So we'll say, we can say print 10 minus I How about that? Cool. Let's try that. Comma just means like you're basically putting two things together. Like you're not really concatenating them like strings, but you're just putting them next to each other. So it's going to print this. It's going to print a space, and then it's going to print this. That's what's going to happen. You can put as many arguments as you want inside a print statement, all separated by commas. But we only need 2 for right now. So let's see if that works. Okay, nothing happened. That's a great start. Let's try something else. I don't know if it's just freezing or if it's not. Ooh. Okay, it's freezing. It's freezing. Oh, it's right there. All right, guys, something weird's happening. We're having like really slow responses. But let's try this. Okay, we already have a problem. There we go. Hopefully that works. basically just an off by 1, right? Because I hasn't actually decremented. I is still 0 here. So after we get the wrong number, right? Because we start off I at 0, we're gonna have 10 minus 0. I guess we could just do 9 minus I. It's probably a lot easier. Kernel's being super slow. We'll try again. Here we go. All right, this is looking good now. Our print statements are coming in the right order. Something weird was happening earlier. But hi, welcome to the number game. Please enter your guess. We'll say 10. Incorrect guess, too low. 9 guesses left. So let's actually try and beat the game within our 10 guesses. So let's try 50. Too low. Let's try 75. Too high. Let's try 66. Too low. Let's try 70. Too high. Okay, so 66 was too low. 70 is too high. There's only 3 more possibilities. I hope it's the number. Oh, come on. Oh, shoot. Okay. Whoa, guys, we got it. Great, great, great. So we won the game with 2 guesses to spare. Pretty great, if you ask me. Albert, let me answer your question. So there's 2 ways to do print statements where you're trying to mix in numbers and strings, right? You can either do them the way I did, where you just use print statements where each argument is separated by a comma, and in that way you don't need to convert this. But there's something called string concatenation, which basically uses the plus sign to basically smush 2 strings together. In that case, yes, we would need to use string conversion, like this. This would work perfectly fine because we have we're converting the number 9 minus I to a string, and then we're concatenating it with this string, which basically means smush 2 strings together. And then we're printing just that one thing. See how there's no commas in this print statement? Because when there's commas, it means you're printing multiple things, and they're separated by spaces. Cool? Does that clear it up, Albert? Like, this would work the exact same way. You could say 75. We forgot to put a space, so it's smushed here. But if you just put a space in this string right here and guessed again, it would work totally fine. We're having some kernel problems. Sometimes it's really slow. All right, so if we said 78, it works perfectly fine. Like here it's just variable. This gets computed, 9 minus I. This becomes a number. We turn it into a string, concatenate it. Alternatively, we could just go with what we said last time, which is 9 minus I. This is a number. This is going to be an integer, actually. Comma, and then we don't need a space because this comma puts a space there for us. Cool. So guys, that is the number game. So we went over an outline of how to do it in plain English. We went over the flowchart of how to draw it in an annotated flowchart using while statements and conditionals and statements and everything. And we also coded it up. Works great. We played it a couple times. This is basically the time is remaining. If you guys have any questions about anything else, assignment stuff, Python stuff, course stuff, let me know. I can try and answer. Why did you use for instead of while? So we only used for because somebody asked if we could have a fixed number of guesses. We used a while loop because we want it to go on forever. So basically, our looping condition was as long as the guess isn't equal to the number, keep going. Keep getting more guesses. But since we wanted to have a set amount of guesses, for loops are generally used when you know exactly how many times you want to loop something. Ooh, yeah. Wait, let me just finish this. Right. So we use for loops. We use for loops when we want to do something a set amount of times. This doesn't have to be an exact number. This can be a variable, but that variable will still hold a number, right? We can say like an x here, and we can have right. We can say guess limit, and we can have at the very top here guess limit equals 10, right? And we can change this whenever you want to 20, and it'll automatically update this. So for loops are used when you want to do it a set amount of times, because you can say for I in range and then put a number here. For and while, close. You can actually represent any for loop as a while loop, but not the other way around. That's an important limitation you need to understand. Because while loops have something that for loops don't. For loops have a looping variable. But with while loops, you can just make your own looping variable. But while loops have the whole fact that you can keep running them. Like you can run them an unknown number of times. When it's based on something like user input, you don't know when the user is going to guess the number correctly. It could take him 10 tries, it could take him 20 tries, it could take him 30 tries, who knows, right? You could use a while loop here. You have to use a while loop here, because if you wanted to just keep going until they guessed it right, well, you don't know how many times you're going to loop. So you need to use a while loop. But you can use a for loop when you know exactly how many times you want to run it. For example, if you have a certain number of guesses you want to implement. Alyssa asked, if we don't guess correctly within the amount of guesses, where would we put game over when you're done? Game over was right here, even with this for loop. So we have a certain number of guesses. We said it's going to be 10, right? Basically, every time we loop, right, we ask, is the guess equals the number? And if it is, we do a bunch of stuff, like tell them whether they're too high or too low and get their guess again. But if their guess is equals the number, which is this else statement, then we tell them you've won, you guessed the number, and we break. I just realized that you guys might not know what breaking is. A break statement is a statement that breaks out of a loop. So this break statement will say, it'll ask a question. It'll say, which loop am I in right now? Well, we're in this loop, and it'll say break out of it, like cancel that loop, like just kind of like skip whatever's left and just go to the next thing. So if we had more code down here, like print high, for example, this break statement would like, let's say we had run this loop, because guess limit here is 10, which means this for loop should run 10 times, right? If we were on guess number 5, right, and we guessed the right number, so guess is equal to number, we're going to say you guessed the number, and then we're going to break, which means we're not going to do the remaining loops. We're going to cut out of it right there and go to the next part right here. I hope that makes sense. Breaking is just used to instantly escape a loop and go to whatever's next. Does anyone have any other questions? You're just talking about hexadecimal stuff? What's going on? Is this an assignment statement or an assignment problem? All right. Yeah, if anyone has any other questions, feel free to ask them. If not, we're basically done with the content for today's tutorial. All right, I'm gonna stick around for like 5 more minutes, see if anybody asks a question, and after that we can end the stream, and I'll see you guys on Wednesday. Thanks for coming. No problem, guys. Thanks for coming, and I hope you found it helpful. For assignment 2, question 3, Inky will play on Tuesday and Thursday if the day of the month is not divisible by 4. Blinky will play on Saturday and Sunday if the day of the month is not divisible by 4. Pinky will play if the day of month is divisible by 4. Clyde will play the rest of the day since nobody will play. I'm wondering if you're correct. You are correct, Stinson. No problem, guys. Thanks for coming. That's exactly how it worked. There was actually a flaw in the wording earlier, but Professor Moore updated it and posted an announcement to Avenue, which clarified exactly when Clyde's going to play. But yeah, that logic is correct. And yeah, Pinky has priority. So Pinky will always play on the day if it is divisible by 4. If it's not divisible by 4, then you can ask, well, who should play here? But if it is divisible by 4, then Pinky will he will take priority and he'll play on that day. Sorry, can you also explain what pass does? Yeah, sure. Pass is actually a really boring and simple Python statement. It does absolutely nothing. Pass literally does nothing. So if you pass, it just doesn't do anything. The only reason pass exists as a Python statement is for cases where you actually need to have something syntactically. So in this cell, for example, let's say we had a function called myFunction, and we said print, hey, like this, right? We need to restart our kernel first. Right, it worked, cool. So now we can call this function down here, and it'll print, hey. The reason you'd use pass is because in Python, let's say you knew you wanted to make a function, but you still didn't want to fill it in yet. Then you just leave it empty, right? Nope, because you're going to get an error, right? If I know I want to make a function called square root that just returns the square root of a number, right? But I don't want to fill it in yet. I just want to wait for a while. Like I know I need this function, but I don't want to write it yet. You can't run Python with a function definition and nothing in there. So we would put pass in there, and now it runs fine, right? That's sort of it's a very almost useless function. The only reason it exists is to not give you an error when you want to have like an empty function. Does that make sense? All right, since let's take a look at the I'm gonna take a quick look at assignment 2, question 3B. I'm pretty sure. So we're gonna go to assignments, and we're gonna take a look. Okay. So what exactly did Professor Moore say? Let's take a look. He said, oh, is it updated here? Oh, here it is. It is updated. Perfect. So every day there's one person playing, and he gets to play pinball on days that start with the letter T. So let's do some basic. Obviously I can't code the answer for you, but I can try and help you out with the logic. So Inky plays on days that start with letter T. Actually, let's start with Pinky because he has priority, right? Pinky, any day divisible by 4, which means mod 4 equals 0, right? Inky, afterwards, he gets priority for Tuesdays and Thursdays. Blinky gets Sunday and Monday. Did you say Saturday and Sunday? Sinson, I think earlier you said you said Blinky will play on Saturday and Sunday, but he is actually going to play on Sunday and Monday because Blinky gets to play on days that follow days that start with the letter S. Is a very, you have to be careful with that. So which days follow the days that start with the letter S? Well, Sunday follows Saturday and Monday follows Sunday. So these are the days that Blinky's going to play. Do you see what I mean? Yeah. Yeah, of course, no worries. All of the test cases should come out to be correct. Earlier there was a mistake, but now that Professor Moore has fixed the wording, all of the test cases should be true. And if for some reason you still think they're wrong, just let me know in Piazza or something, and it should be good. Cool. And Clyde gets to play on the rest. Does anybody have any other questions? No problem, Simpson. For the second else in the code, I received an invalid syntax error. In which code? In the code that I was writing for this tutorial? Are you talking about this code, Kevin? Second else in the code. Not this one, this one. You might have a syntax error because it's tabbed in. Make sure that it's not tabbed in. This is wrong. If you have your else statement tabbed in, I think I'll get a syntax error too. Here. Good night, guys. Have a great night. I'll see you Wednesday. Yeah, see how I got a syntax error? I don't even know if you're still here, Kevin, but if you are, this is why. You need to make sure that this is tabbed back out here. Because this else statement is with respect to this if statement. We're saying if this isn't true, otherwise, do this, right? All right. Hope that clears things up. All right, guys. It looks like there's no more questions. So for anyone who's okay here, explain the ungraded question in assignment 2 using the s.count. I'll try and find out what you're talking about. Oh, this thing. What do you mean by using the s.count? I can explain what the question's asking, and I can explain. I can give you guys the solution for this one because it's not worth anything. It's really pretty simple. So, okay, I'm guessing you're talking about Python's count function. Python's count function basically it checks a string for a certain substring and gives you the count of that. The reason I don't think that's the best idea is because you would need to individually check the count of all the different vowels. I think that's pretty inefficient because the code's going to be really bulky. I think a much better way here is to just check every single letter in the string, every single character, see if it's a vowel, and then increment some counter by 1, right? So you could say for character in S, first we should probably say, here's our vowel count. We're going to start it off at 0. For character in S, if S is in, so here's how you traditionally do it, right? You say if S, if character is equal to A or character is equal to E or I or O or U, then vowel count plus equals 1, right? That's how you do it. And basically this would go through every single character in the string one by one. It would check if it's a vowel, and if so, it would increment a count by 1. And at the end, you could just return the vowel count. Now there's a problem, is that this is super bulky. If we actually wrote out all of these things out, it would be huge, right? It would be a massive line. So what we can do is we can use a keyword in Python called in. We can say in. So we can say if character is in and then some sequence. A sequence can be a list or a tuple or even a string. So we can make a string called vowels that has all of our vowels in it, lowercase and capitals, as you can see. And now we can say, it becomes so much easier. We can say if the character that we're talking about, if the character that we're looking at right now is in vowels, which means if this character is in this string, then vowel count plus equals 1. And now, if you run this, you get true for the first case, you get true for the second case. And this will work on all cases because this is the correct solution for this problem. I think this is the most natural way of solving this problem too. Like if you ever wanted to count the number of vowels, well, you'd go one by one, check each character, and count how many vowels are. Let me know if that makes sense. I just hope you see how using count would be a bit inefficient because I don't think you can use count to see if there's like multiple different things. I think it has to be one set substring. Yeah, no problem. No problem. Glad it helps. Oh, yes. Yeah. Okay, Lang, great question. Where is it? So I completely forgot. I should have mentioned this. Plus equals 1 is basically just a shortcut. It's shorthand for saying this. It's exactly the same thing, right? Because when we say this, we're basically saying vowel count becomes vowel count plus 1. So we're updating this, which all we're doing here is incrementing the value in vowel count by 1. So we can, like, it's those two are equivalent. These two lines are exactly the same. This is just a shortcut. So if we actually wanted to do this, the shortcut would just be this. It means increment vowel count by some number. Hope that makes sense. Cool. Great. All right, guys, thank you so much for coming to the first tutorial. The next tutorial, we're basically going to go through some coding practice problems for Python and do some like logic challenges and string challenges. It's going to be a good time, so I'll see you on Wednesday. Bye, guys.